Okay, so today we're going to talk about the exponential product rule. And the product rule comes from something that we all kind of know a little bit about. So I'm going to back us up just a little bit and talk about that. Let's say the product rule. I end up with a squared. Well, we know that a squared has originally come from some place. So if I back that up just a smidge, I say that a times a gets me a squared. Well, quite simply, if we don't have an exponent behind our base, we do. It's to the first. So our product rule now says, and we can kind of get this from our answer that we already knew about, that a to the 1 plus 1 gets me a squared. So the easy thing about this would be that all we have to do is recognize that we have the same base, and we're multiplying the same base. We add our exponents. So therefore, if I wanted to take n squared times n to the 7th, I don't have to break that down and go n times n, and then times n, and 7 of those all times each other. All I would really have to do is state that, yes, I have base n, and 2 plus 7 is 9. Well, we can do this over and over and over again. The length in multiplication really doesn't matter, neither does the order. So if I say that I have n cubed times n squared times n to the 5th, I still have base n, but now I have 3 plus 2, which is 5, plus the other 5, which is actually 10, and it makes my life a little bit easier, thus making things faster. Now, as we all understand in math, things get a little bit longer. So therefore, let's make it a little bit longer. Let's say I have a squared b, let's make it squared 2, times a to the 4th b cubed c times a squared b cubed c, and let's make that to the 5th. Well, real easily I can say, yes, I have a, so I have base a. I have 2, a 4, and another 2, which makes 8 of those times each other. I have base b. I have a 2, I have a 3, which is 5, and another 3, which also makes this exponential 8 as well. And then I have a c. Well, just because I don't have a c in the first term doesn't really mean anything. Actually, they're all still the same term, but just because I don't have it in the a squared b squared doesn't really mean anything. I still have c's. So I have 1 and 5, which is 6 of those. And as you can see, that makes my life just a little bit easier. When I recognize that I'm multiplying bases, all I have to do is add the exponents. Now, this does work with numbers too, and we like to think that numbers work so much easier because there's something we're a little bit more familiar with. The problem with numbers is it's exponential, which means they get large in a hurry. So yes, let's take 2 cubed times 2 squared. Yes, we're multiplying by the same base. So how many 2's do I have? Well, I have 5 of those. Well, 2 times 2 is actually 4. Times 2 is 8. Times 2 is 16. And times that 5th 2 is 32. Well, that's the simplified answer in this case. And yes, our book will do a few different things with it. Okay? They'll make that so large that we have to go to scientific notation to actually record the answer. Yeah, I would like for you to understand why things are and how they work. So let's take a negative 9. Let's take it to the 7th. Let's take it times another negative 9, and let's take that guy to the 5th. Yes, exponents only apply to those things in front of them, so the parentheses. Inside my parentheses, I have negative 9, and 7 plus 5 is 12. Well, that number is very, very, very large. And although, yes, we can take a negative times itself 12 times, we do get a positive. 9 times itself 12 times is a very, very large number. So yeah, I'll accept that is our answer, but do understand there's an actual number out there that represents that value. So, and last but not least in the product rule, when our bases are numeric and they are not the same bases, we still use them as regular numbers. So here, let's say I have 7. I've got an m squared n. Let's take that times a negative 2 m n squared, and just let's make it a little bit longer. Let's make it minus 3 m n. Well, our numbers still work as numbers, and 2 negatives make a positive. A 7 times 2 is 14, times 3 is 42. So our numbers, as you see, just because they're not the same basis doesn't mean they can't work as numbers as well. However, now we are multiplying by m's. I have a squared, a 1, and a 1, which 2 plus 1 plus 1 is 4. I have some n's. I have 1, a 2, and a 1, which 1 plus 2 plus 1 is, again, 4. And that's pretty much a quick summary of what your product rule is.